Hello friends, I welcome you in lecture number 7 on binomial distribution. In this lecture we will discuss one example on binomial distribution, and before going for that example we try to understand this remark or note. So suppose we have n independent trials and these n independent trials make one experiment, or suppose one experiment is made up of n independent trials, and suppose this experiment be repeated capital N times. So we have n independent trials which are making one experiment, and that one experiment is repeated capital N number of times. Then if we are asked to find out expected frequency of x successes in these n experiments, then it is given by n times probability of capital X equal to small x. And because we have binomial distribution, this probability mass function is defined in this way: ncx p raised to x 1 minus p raised to n minus x, and we multiply by capital N. So again we repeat, suppose one experiment is made up of small n independent trials, and suppose this one experiment is repeated capital N number of times. Then if we are asked to find out expected frequency of x successes in these n experiments, then we have to multiply this probability that x equal to small x by capital N. That is, we have to multiply probability of x successes by capital N. So we understand with the help of example. Out of 800 families with 4 children each, that means there are total 800 families, and in each family there are 4 children. So we are asked to find that how many families would be expected to have 2 girls and 2 boys, at least 1 boy, no girl, at most 2 girls. That means we have 800 families, and for each family we have 4 children. So if we consider one experiment, that if we consider one particular family, then for that family we have 4 children. So we can consider small n equal to 4. So we will consider our experiment as to examine the gender of a children in one family. Again I repeat, we consider our random experiment as to check the gender of a children in each family. So in each family there are 4 children, so we consider n equal to 4, and for each child we have to check whether it is a boy or girl, and this experiment is repeated for 800 families. So we consider capital N equal to 800. There are 800 families, and we are asked to find out that how many families would be expected to have this type of events. So first we will find out probabilities for these 2 girls and 2 boys for one family, and then we will multiply corresponding probability by capital N. Probability that x equal to small x will be multiplied by capital N. So before that, first we write that given that there are 800 families, and it is given that each family has 4 children. This is n. So we consider small n equal to 4 and capital N equal to 800. So we concentrate on this small n equal to 4 trials, means for each family we have 4 children, and our random experiment is to check whether each child is a boy or girl. So we can define success as either child is a boy or child is a girl. So we consider that success is defined as child is a boy. So random variable will be number of boys in a family, in one family, and in one family there are 4 children. So the possible values of random variable will be from 0 to 4. The possible values of random variable x are, there are chances that in one family there is no boy, that means x is 0. There may be one boy, there may be 2 boys, 3 boys, and maximum possibility is 4 because there are total 4 children in each family. Now here it is given that assume equal probabilities for boys and girls. So the family has a boy, probability of success. So probability of success, that is probability that family has a boy, is 1/2. Okay, they have given that assume equal probabilities for boys and girls. That means probability that family has a boy is 1/2, as well as probability that family has a girl is also 1/2. So we can see this is a binomial random experiment because number of trials are 4, they are finite, also they are independent, and for each family there are only 2 possible outcomes, either child is a boy or child is a girl, and the probability of success is 1/2 for each family. So all the conditions of binomial random experiment are satisfied. So this is x, this x is a binomial random variable. So therefore we can write x is a binomial random variable and its probability mass function is probability that x equal to small x is ncx p raised to x 1 minus p raised to n minus x. X is from 0, 1 to up to n. So if we put values of p and n, so we obtain n is 4, so 4cx, p is 1 by 2, that is 0.5, and 1 minus p, that is 1 minus 0.5 is also 0.5, and here we write 4 minus x. X is from 0, 1, 2 and 3. So this we can simplify again. Probability that x equal to x is 4cx. This we can write as 0.5 raised to x plus 4 minus x. That means 0.5 to the power 4, and x can take the values 0, 1, 2 and 3. So this will give me the probability of x boys in a family. This is the probability that there will be x boys in a single family. Now if I want to find out the number of families having x boys out of 100 families, then I will multiply this probability by n, which is 800 here. So this will give me the number of families having x boys. Okay, so first we will find out probability for each family, and to find out the expected number of families we will multiply by 800. So we start with first part. In first part we are asked to find out that how many families would be expected to have 2 girls and 2 boys. So first we find the probability of this event, probability of 2 girls and 2 boys. So first we find out probability that in a single family there are 2 girls and 2 boys. So 2 boys means the corresponding event is x equal to 2. Small x has value 2. So we can put x equal to 2 here. in this formula we put x equal to 2, so we have 4c2 times 0.5 raised to 4. So this we can simplify as 4c2 means 4 into 3 divided by 2 into 1 into 0.5 raised to 4. So here we have 6 times 0.5 raised to 4, and I can use scientific calculator to find out this value. So let me use calculator, and using scientific calculator this turns out to be 0.375. So probability of 2 boys and 2 girls is 0.375 in a single family, and we are asked to find out number of families expected to have 2 boys and 2 girls. So therefore the number of families expected to have 2 boys and 2 girls is equal to capital N times probability that x equal to 2, which we have calculated. Capital N is 800 and this probability is 0.375. So if you multiply these two, you will have 300. So there are 300 families expected to have 2 boys and 2 girls. Okay, so in first part we are asked to find that number of families expected to have 2 boys and 2 girls. So the number is 300. Now we find out second part. In second part we are asked to find out number of families expected to have at least 1 boy. So first we find out probability of the event at least 1 boy. So now we do second part, probability of the event at least 1 boy. Now our random variable capital X is number of boys in a family. So at least 1 boy means possible values of X are 1, 2 and 3. Okay, so this we can rewrite as probability that X is greater than or equal to 1. So we can find out in this way, probability that X equal to 1 plus probability that X equal to 2 and plus probability that X equal to 3. Or we can use that concept of complementary event. Okay, the event which is complementary to this event is probability that X is less than 1. The probability of at least 1 boy has complementary event probability that X is less than 1. That means there are 0 boys. So this we can rewrite as 1 minus probability that X is less than 1 and possible value is X is less than or equal to 0. And we have only one value, X is less than or equal to 0 or X equal to 0, and this we can find out using this formula for probability mass function. We put X equal to 0 here, so we have 4C0 0.5 raised to 4. So 4C0 0.5 raised to 4. 4C0 is 1, so we have to find out 1 minus 0.5 to the power 4, and if I calculate this I have 0.0625 and this turns out to be 0.9375. So probability of at least 1 boy in one family is 0.9375. So therefore the number of families expected to have at least 1 boy is equal to 800 times this probability 0.937. So if you multiply these two, we arrive at 750. So out of 800 families, the number of families expected to have at least one boy are 750 families. Now we consider third part. In third part, we are asked to find out probability of no girl, or we are asked to find out number of families expected to have no girl. So first we find out probability of no girl in a single family. So probability that family has no girl. So if there is no girl, that means probability that all children are boys, and there are 4 children, so this is equivalent to the event that all the children are boys. That means there are 4 boys. So we have to calculate probability that x equal to 4. So again we use that probability mass function. We put x equal to 4 here. Okay, in this we put x equal to 4, so we have 4c4 times 0.5 raised to 4. So 4c4 times 0.5 to the power 4. 4c4 is 1, so we have to find out 0.5 to the power 4, and it turns out to be 0.0625. So this is the probability of no girl in one family. So the number of families expected, the number of families expected to have no girl will be equal to 800 times this probability, 0.0625, and if you multiply these two, answer will be 50 families. So there are 50 families which are expected to have no girl. And now we come to the last part. In last part we are asked to find out expected number of families having at most 2 girls. Okay, in last part we have to find out probability of at most 2 girls, and then we will multiply with 800 to find out expected number of families. So probability of at most 2 girls. So at most 2 girls means number of girls can be 2, 1 or 0. Okay, so we try to understand this event. At most 2 girls means there are 2 girls, 1 girl or 0 girl. So if there are 2 girls, there will be 2 boys. If there is 1 girl, then there will be 3 boys, and if there is 0 girl, means there all the children are boys. So this event, probability that at most 2 girls, is nothing but union of these 3 events, and all these events are mutually exclusive. Okay, so we can rewrite this as, because all these events are mutually exclusive, this probability of this event will be equal to sum of probabilities of these 3 events. Probability that has 1 girl and probability that 0 girl. Again I repeat, probability of this event, the event that at most 2 girls, this event is union of these 3 mutually exclusive events. Okay, all these are mutually exclusive. One event can happen at a single time. If one occurs, then it stops the occurrence of remaining events. So all are mutually exclusive events. So probability of this event will be equal to sum of probabilities of all these 3 events. So now we consider all these probabilities. Now this is equivalent to, there are 2 boys here, so this event can be written as capital X equal to 2. Here there are 3 boys, so this can be written as probability that X equal to 3, and there are 4 boys here, so this can be written as x equal to 4. Now we use that probability mass function which we have derived for this. It is 4cx 0.5 raised to 4. Probability that x equal to small x is 4cx 0.5 raised to 4. So for first probability we put x equal to 2, so we have 4c2 0.5 raised to 4. For second event we put x equal to 3, so it is 4c3 0.5 raised to 4, and for third one we write small x equal to 4, so we have 4c4 0.5 raised to 4. So we have 0.5 raised to common in each term, so that we can take outside this, and we write 4c2 plus 4c3 plus 4c4. Okay, let me correct this. So this is now 0.5 raised to 4. 4c2 can be simplified as 4 into 3 divided by 2 into 1. Then this we can rewrite as 432 here, 3 into 2 into 1, and we know that 4c4 is 1 because NCN is 1. So now we simplify all these things. 0.5 raised to 4, here 2 will cancel out, so we have 6. Here we can cancel out 3 and 2, so we have 4 plus 1. So this is nothing but 10 plus 1, 11. So we have 0.5 raised to 4 into 11. So this turns out to be 0.6875. So this is the probability that there will be at most 2 girls in a single family, and we are asked to find out the number of families expected to have. We are asked to find out the number of families expected to have at most 2 girls. So this is equal to total number of families into probability of at most 2 girls that we have obtained here, and it is 0.6875. Okay, so we multiply this by 0.6875 and we will obtain 550 families. So there are 550 families expected to have at most 2 girls. Okay, so in this way we have done all the parts of this problem. What is new thing in this problem is we have one experiment, and that experiment is to check whether children is a boy or girl in a single family, and there are 800 families. So that experiment is repeated 800 times, and we are asked to find out expected number of families having all these events, 2 girls and 2 boys, at least 1 boy. So what we have done, we find out probability first for a single family, and then we multiply by 800, that is total number of families, to obtain expected number of families to have this type of events. Okay, so we will remember this remark that if we have one random experiment having n trials, and if that random experiment is repeated capital N times, then expected frequency of x equal x successes in those n experiments is given by capital N times probability that x equal to small x. Okay, so this is all about this session. I hope you like it. Thank you very much.